Hey everyone, we are going on to 6.3, one more type of confidence interval. It's a population proportion, so no more means. 6.1 and 6.2 were means. This one's on proportions. So you won't see anything about a mean or a standard deviation. That's how these stick out. These will have decimals, percentages. Okay. Our notations, we have P. P is the population proportion, and P hat is the sample proportion. So lots of P's here, and then just separated by a little hat. So add those to your variable list. And we have a little formula to find P hat if need be. Sometimes it's just given. Sometimes we got to calculate it with x divided by n. And we'll also have a Q hat. That's just the 1 minus P, like from chapter 3. So let's suppose you had a survey of 80 ARC students. 46 said they prefer dogs. P hat, what's P hat? I would just take the 46 divided by the 80. Right? Usually, always x is smaller than n, right? So the smaller number should be on top. And that converts that to 575, or in other words, 57.5% of the population prefers dogs. How about Q hat? That's not a Q. That's a Q. I just do 1 minus the P hat. That's 425. Yeah, that's it. Okay. And then when we construct these population proportions, that just looks familiar, right? It's just instead of x bar, like in 6.1 and 6.2, we have P hat. It's still a sample statistic. E is the margin of error. We get to a formula for that in a minute. But real quick, what if we have the confidence interval like that? Find the P hat and the margin of error, just like we did in 6.1, right? The P hat should just be right in the middle. And right in the middle of those two endpoints, I could just add them up and divide by 2. Right, it's like you're finding the average of the two endpoints. That's calculated to 0.554 on my calculator here. And then the margin of error is always the distance from that middle to either of the endpoints. So a good way to do that is just take, our little trick is going the margin of error. I can just write that as again, margin of error minus the lower limit. So margin of error, not the margin of error, the x bar, let's reverse that. Good thing this thing just reverses. Start over. We don't have x bar. We have P hat, right, as the middle, minus the lower limit. It's similar to 6.1 when we were using the x bar, but now we have the P hat. So it's the sample proportion minus the lower limit, basically the distance from the middle to the end. Right, so this is 0.554 minus 0.525, and 0.029 would be the margin of error. Okay, so those problems work out similar to what we've been doing. Just new notation that I got to remember to use. Okay, here's our steps. So when we go through finding confidence intervals for a proportion, we're going to have to find that P hat first. This verification step, we might just wave our hands a little bit, but there is something we do have to be careful of, making sure the sample size is big enough, basically. So that's those two little formulas. Critical value is a Z. Woohoo! It's back to 6.1. So no T for this one. We're back to Z. We can use that little table at the front of the 6.1 packet if we want to find critical values, same as 6.1. Margin of error formula is the one new thing here, right? So we got P hat, Q hat, N. All right, so we know what all those things are. We'll be able to calculate that. And then still doing that same kind of thing, add and subtract to the sample statistic. Just in this case, it's P hat instead of X bar. And then interpretation just uses the word proportion instead of mean. But otherwise, let's give it a go. So for number 3, let's write out our variables. So P hat is going to be that 46 divided by 80, which we just did in that previous page, but I'll just write it again here. Q hat is always 1 minus that. Okay, so I get those two. I need the n. N is always the bigger number. Usually there's only two numbers given in the confidence interval, right? The n is the bigger one. It's 80. The confidence level is 0.95, which leads us to a ZC. And that's the little table at the beginning of 6.1. Maybe you already have that one memorized. It's 1.96 if you look it up. And that gets all our variables written down. Okay. Now we're going to go to margin of error. And that formula above, ZC square root P hat, Q hat divided by N. And we got all that stuff here, right? So ZC is 1.96 square root P hat 0.575 times 0.425 divided by N 80. Whew, there we go. That's what we got to put in our calculator. So be a little bit careful when you're putting it into your calculator. Make sure all of that stuff is inside the square root. So you might have to use a set of parentheses like that when you're putting it into your calculator. Depends on the model of your calculator. So I'll do a quick calculation on that just to make sure that looks right for us. So if I go to my calculator app, I put in 1.96 first, and then times, and then I got to put square root. So that's second x squared square root. There it is. And then 0.575. And mine, notice my square root bar is getting longer, so that ensures that everything's underneath. So I don't need parentheses for my model. Right? And then divide 80. Right? So I put mine in just like that, and it works out. Okay. And let's take this out to a few decimal places. So I'm going to go 0.1083 just to be on the safe side. So 4 decimals. So it's about 0.1083. That's because my final answer wants 3, so I should go at least 4 in any preliminary calculation. Safer would even be 5 or 6. Okay, and then finally we're doing P hat plus minus E. Right? So I'm going to do the P hat, which, what was P hat again? Oh yeah, 0.575. Right up there. Minus 0.1083, and then 0.575 plus 0.1083. And this will give me my final answer, 0.467 to 0.683. And I can say the interpretation, I won't write it because I'm not in my room, but we are 95% confident that the true population proportion is between 46.7% and 68.3%. Right? So we've captured that population proportion, right, of the percentage of people that like dogs. Okay. So there we go. All right. Here's another one. I mean, we're going to get a little extra practice here. So this one, sometimes it just doesn't work out so nice, right? I got my n, my x given, right? So I'm going to do 1422 divided by 1306. And this just has a bunch of decimals. So I like to be a little bit careful here and just take it out, maybe at least 5 or 6 places, right? Just to, again, ensure accuracy. Because I sure do hate to be off by like a 1/10 when I'm doing my lab. Makes me want to throw my laptop. So let's just be careful and not have that happen. That's not an 8, that's a 5. So let me write that a little bit clearer. So it's 0.55646. Okay, so there's the P hat and then the Q hat. And I know my N is the bigger one, 3206. We've got a C99, which leads me to the ZC, which if you look on the little table, 2.576, beginning at 6.1, page 83, I think. And we got all our numbers, plug it into our E formula. So it's always the ZC on the outside, square root, and this one's going to get a little long because I got the P hat first, 44354, times the Q hat, 55646, divided by the N, 3206. Ooh, that's a lot of numbers. There's a lot of room for typos when I type this in here. But I'm typing it in. I'm going to calculate this out. So if you want to verify with your calculator that you're getting this too, you might want to just hit pause and try it out. But I'm getting 0226, which looks pretty good. Okay. Okay, so got all our variables. Got the E. Final thing, we're going to take that E, add it and subtract it to P hat. Always back to P hat. Right, so I'm taking the 0.44354, add and subtract 0.0226. And then now I can go my final 3 decimal places. So I like how I have a lot more than 3 decimal places in all my values here. That makes me feel good about accuracy at the end. So when I do my subtraction, I get 421. And when I do my addition, I get 466. Final answer. Okay. Okay, so that's the proportion method, right? So a lot of similarities from what we've been doing, some differences with formulas and different variables, but not too bad. Okay, last thing is back to a problem about minimum sample size. We had one from 6.1. How many people should you ask to be this accurate? Well, now that we have this new E formula, we're going to have a new minimum sample size formula. So that's this one. So again, it's just kind of a manipulation algebraically of the E formula. And what do we put in for P hat and Q hat? If we don't have any preliminary estimates, sometimes we don't, then we can just use 50% for each one. Otherwise, we can use what's given. Okay, and then again, we're always going to round next whole number. Okay, so suppose you're running a political campaign and wish to estimate 95% confident those that will vote for your candidate. Your estimate must be within, there's your margin of error, within 3%. Find the minimum sample size. Okay, so 95%, we know that one. ZC is 1.96. Notice no preliminary estimate available. So we're going to be using P hat as 0.5 and Q hat as 0.5. And then we know our E is that within, but just make sure to write it as a decimal. So 0.03. And that's everything that's in the formula. So we can plug it all in. N is equal to P hat, so 0.5, times Q hat, which is 0.5, parenthesis, ZC, 1.96, divided by E, 0.03 squared. Okay, type into your calculator. This one's pretty straightforward when you type it in. Give it a try, you should be getting 1067.11. Even though that's that little 0.11, minimum sample size, always rounding up, 1068 voters. And there we have it. Okay. So that's how those work out. Just, it's a really nice formula because, gosh, you wouldn't want to ask 6,000 voters, and you don't even get that much more accurate with your margin of error, but you sure do waste a lot more time. So it's nice to know just the number that you need minimally to get the accuracy that you want. And a lot of political polls, even when they're national, are like right around 1,000. Probably using that formula. Okay, how about one more? We got 90% confidence, proportion, within 4%, margin of error, prior study, 32, P hat. Okay, so P hat, 0.32. Q hat, 1 minus that, 0.68. C, 0.9. which leads us to the ZC little table. I'm gonna go back and look. I think that, oh yeah, I know that one. 1.645. That's that one. Okay. And those are all the variables, right? Oh, E. Make sure to just write that as a decimal. 0.04. Don't lose that 0. It's not 0.4. It's 0.04. Okay, N is, so now we're going to go 0.32 times 0.68 because we have that preliminary estimate. So we're no longer using 0.5s. 1.645 for the Z, 0.04 for the E, square, calculator, type. And let's see what I'm getting here on my calculator. Oh, it's just so close. 368.0194. Even though that's a tiny little decimal, still rounding up. Feels weird, right? But we're still going to 369. 369 what? Adults. Okay. And that's the end of chapter 6. So give the homework a try. Hope it goes well. If you have any questions on anything, that is the end, right? Yeah. Okay, good. Yeah, if you have any questions or anything, let me know. And otherwise, I'll see you in chapter 7. Talk to you later.